Welcome to the Dev Banner. This is Eric. This how-to video is about errors. And even the best developers introduce, see, and frankly, the funnest part of a job is finding those errors and fixing them. So they are inevitable, and they creep into our code, and no one is immune to this. So errors are errors from a language to language. Uh, Frankly, I don't see much difference other than everybody else in Go. So if you take a look at Python, for instance, the pattern that most languages that I've done in the past is the try-catch exception pattern. And that is, you have quite a bit of code, and something may trigger an exception. And as long as it's between that try and catch or try except, in this case, with the Python then code, then the exception will trigger, and that error will rise, and you take care of it after that. Now, that's the other languages do that, and like I said, I've written plenty of other languages that did try catch, and honestly, I felt like the try catch is okay, but I always struggled with it. And the reason why is you just code. You're going along and you're coding, and most times you don't think about erroring, and then you put it out, you put your code out and run it, and it errors out because there was some network error, or you're divided by zero or something like that, right? And then you're like, oh, I get crap. So you could go put a try catch in there, and you find your exceptions and stuff like that. So it just seems like you're catching an event. And Go does something a little different. And Go's philosophy in errors is quite a bit different. And in this case, you'll see that just a really quick code here, that there's a couple ways that you can, and this is pretty familiar, that you do some kind of work here and you return an error, or you do some kind of work here and you send back more than errors. Now, just the pattern wise, when you're dealing with sending back error, if it's, in this case, this int, it always comes first and errors always last. And just wanted to point out that the FMT package has this error f that will create an error, or you can actually just call the errors.new with a string, and that also creates an error. So there's a couple examples there. And then to handle them, this is a familiar pattern. This is condensed error checking, where you can, and this you can do this with a lot of things, but this if statement, or you'll see this a lot. And once again, if this int was up here, as here, this, if this was an if statement, then that I would be locked into this scope, and you wouldn't be able to use it out here. So sometimes you have to do it this way versus this way, but this one's easier to kind of read and just deal with because it's condensed block. So why did the developers in Go change kind of this pattern from a try catch exception block to this error? And one of the creators of Go, Rob Pike, he mentioned this in one of his blogs. He wrote, and I quote, "Errors are values, and since errors are values, errors can be programmed." Now, I thought about that as I read it, and it kind of made sense to me that my Go treats errors as a first-class citizen, meaning it's part of the code. You have to deal with it. It's not this whole, oh, I got to try catch. Now, you can disagree with me, and we all have their opinions, but that's kind of how how I felt about try catches. And errors are there. They're just part of the language, and you have to deal with them. And so, in the end, you feel like you're doing a lot of this, and I get that. And in that article, that blog post by Rob Pike has a really neat suggestion in how to deal with if you have a lot of these in, like, maybe like a function or whatever. But anyways, I will link that to in the comments. And so whether you have a love-hate relationship with errors, especially in Go, this is how they deal with them, and but have a good, go read that blog post and see what you think. So on to the next example. So I pulled up this next example, and in order to handle errors better, and frankly, this whole pattern that errors are a value, you can create your own error, and as long as it has this method on it, this struct, then it's fulfilling the interface of error. So if you come back and look at error, it's just an interface, and the signature is error with a string, returning of a string, and that's all you have to do. And so here's where I think the beauty of the errors package and what Rob Pike's saying about his value is you can add as many fields as you want to the struct, and now you've got lots of values that you can deal with and manipulate and check or whatever. So in this case, you'll see that I am going to do some work, and I'm going to create a custom error. I have an error here, and then all that does is it prints out when I do this print line. It will go and say, hey, I'm an error, so give me the string, and it runs this, and you're just printing out the message. So if we ran this, you get this message right here. So that's a really example of how to do more custom error. And so let's look at another example. Okay. So this example is a little bit more complicated. So I'm doing some more stuff. I'll come back to this in a second. But the main thing I wanted to show is now I have this struct that has a couple more fields in it. And this is actually one of the it's a condensed version of a struct that I use in my APIs, but I handle, and I'll show you how to make this error package a little bit more customizable for what you need. So I just want to show you that I'm taking this struct and I'm going to marshal it out to really just a string. So we're gonna take it, make a JSON string out of it and print that. So that's basically what the error method is on this struct, so that it fulfills. And I have this helper function called new API, and it looks to see if an error's there, looks to see the detail, and you pass in the things that you want. But the beauty comes is now you can define a bunch of functions that are set in stone, consistent on the messaging you want to get back to the user. So in this case, on this DB read, for instance, I'm sending in a detail, which, you know what, it would be more like a table name, and because you're saying, hey, I can't read this table, and in this case, you can send back a different status code. You can hard code. It will always say table read error, and then the detail field you can now put in the table name, and give the message that's always consistent. And so you can put those in your docs on your API. And so with that, we can do some work, and then we can read some table, do some work. Is I'm just going to create a new API error and send in those things. But the read table is, something bad happened, and we're going to send back this error. So you just send back a new DB read error function, right? And whatever the return is, and the return is an error. And I'm going to say my table, which, is the name of the table I'm dealing with. And, and I'm just creating a new error. So if we go ahead and run this, you'll see that here's that JSON string that has got marshaled, and we just put it a string, and you'll see that the my table is inserted into that string, and the error is also in there too. So it once again, the errors are a value, and whatever that value means to you, you can expand upon it, and the whole thought is you have to deal with that error. So so that's some consistent error handling that you can do in your code. In this next example, we're going to talk about wrapping errors. Now, before 1.13, the way you would handle errors and doing, putting errors together, for example, this errors.new, this inner function would create an error, and then you'd come up and you say, okay, well, I found an error, so I'm just going to go create another error, and I'm going to just put that string of that error within the string and send back a new error. And that, I think, got kind of tedious. And so what they did is they introduced this pattern called wrapping, philosophy called wrapping, on 1.13. And how that works is, let's look at these three functions. So really all it is I'm just going down and calling, do enter again, right? But the bottom is this my error, and all my error is just this variable of a type error that's, so I make a new error and I set the string, okay? And that's all it is. And then I wrap it with this verb of a %w. And then what it does is it takes it takes the whole error and puts it in here. And then at the top, I'm saying top error with error, and it wraps these two errors together. Now you're like, okay, well that's great, but how do you get it out, or how do you deal with it? And so what they've done is they've created two methods, actually two functions, in the errors package, and one is called is, and the one is called as. And all is does is if it finds the target, which is in this case my error, if it finds it, then it just brings back a Boolean. And so I'm going to print error is my error. The as, on the other hand, and let me set this up, I created this custom error, and has an in as the field, and its error method does this. This is my custom error, and it prints whatever's in the in. So, but what it does is it goes and it unwraps every error until it finds of this type, and then it puts that instance of the error in this variable, and then you print it out, and at that point it also comes back as a Boolean because it found it. And so in this case, I am creating this custom error and setting the in to this string, and then at the top I'm putting this top as. And so what you're going to see is you're going to see top as, then this verbiage, and then this verbiage, right? And then when it unwraps and does the adds, you'll see just this verbiage plus this verbiage. And so if we go ahead and do that, go build, and the first one is the do old work, and that's just plain string. But here's your error is my error, and then I'm just printing out the error all together of this custom error right before the as, and you'll see that top as and then the error, and then here I'm printing out can this be from, and I'm printing out that thing. And so here's some functions that will help you once again see the value of errors and separate those values if you're going to wrap errors within errors, and it's kind of a nice little feature. Okay, so the next thing I want to kind of discuss, not necessarily errors, but they're related, and that is panic. And panic is a built-in function that will stop if it comes across something that it can't do, like divide by 0 or go into an array of a certain index and that index isn't there, then it's going to panic. And one of the other really notorious ones is it tries to use a variable that's a pointer, and the pointer points to nil. That will also panic, and panic will just stop the program and log that out to the terminal. So, but there is two ways to really do it. One is through the log, and there's fatal, and I think there's a fatal line and a fatal F. But in this case, we're going to say, wow, semi-explosion. And what log fatal F does is it logs what you give it, and it also puts a nice, date timestamp So, but it still crashes because we didn't get to this print line, right? And so if we do this again, what panic does is it gives you a little bit more information. It gives you the stack trace of where this thing was. So in case your code splits and does, goes down to multiple libraries, and which is very possible, this will give you the stack trace and the line number and stuff like that. And so panic's nice. In the same case, this log fatal is nice, but I would use it sparingly. I would use it only if you feel like you can stop it and give information to the developer or the person deploying the code or whatever. In that case, I've used it when I need the user to, not the user, to the developer or the person who creates the code. You need to tell them some information's missing, like connection string information to your SQL database or something like that. If it's not there, it can't be found, and then it goes to connect, and you panic, and you give the message, and it doesn't really go out to production in that case. So that's panic. It's up to you how you want to use it, and once again, I think use it sparingly. So my last example is having to do with panic, but it has to do with recover. And recover is a built-in function that allows a chance to catch a panic, and then you as a developer can do something. You can repanic if you want, but mostly it's there for processes that like an API that you just, if one user put in some bad data and wanted to divide by 0, for instance, that it wouldn't bring down the whole program. So once again, use it kind of sparingly. I kind of feel like this is a try catch scenario, and I've kind of seen it as that from somebody who really wasn't a Go developer, didn't know much about the language, and didn't know much about errors. But it only can be used in defer. And so in this case, I'm deferring this function. I'm going to do some work, and I am going to panic, and then this thing should recover, and then from there we're good to go. So and that's where this do some work is happening, right? So let's go ahead and go build and run this thing, and you'll see that this print message happened, not the panic. And this is useful, don't get me wrong. There's one of my web server library that I like to use, and I think all of them use a global recover to make sure that it just doesn't, and they'll push out the panic to they'll push out P in this case, and show the stack trace but it doesn't bring down your code or the instance of your code running. So once again, use it sparingly, but don't use it in place of handling your errors. As Rob Pike says, handle your errors. But that's errors and panics and recover. I hope you learned something, and see you next time.
Please subscribe to the channel and make sure notifications are turned on.